Imagine you have a spaceship that can almost instantaneously accelerate you to half the speed of light. Let's also say you decide to go near Sagittarius A star, the black hole in the center of the Milky Way galaxy, and explore it from a safe distance. What would happen if you went near it? Would you be able to escape its gravity? Unfortunately, the answer to that question is no. Inside a star, throughout its life, gas and radiation pressure try to expand the star, while gravity tries to shrink it. Eventually, though, gravity wins out. All matter rushes towards the core and then bounces back, while the core itself continues to collapse. The event horizon is soon formed. We have absolutely no chance of surviving anywhere near the event horizon, because the escape velocity there is the speed of light, so we'll just get sucked in. The core, even after this, continues to collapse, and soon becomes a point of zero size, the singularity. Karl Schwarzschild, a German physicist, solved a set of equations in Albert Einstein's theory of gravity. His solution, the Schwarzschild Metric, described gravity outside and inside a spherical mass. What it tells us is that space and time behave as space and time from a distance, but if you go below the event horizon, space and time actually switch roles. Let me explain. All the dimensions of space are accessible, right? I can move in any direction I want. But with time, we're prisoners of the present. I can't access the future, nor can I access the past in this moment. Now let's peer into the black hole. Imagine the core of a collapsing star and the event horizon right above it. Right before the core becomes the central singularity, it emits one last photon at a distance r away from the event horizon. Let's say we also go into the black hole. We will encounter this photon, but we'll see that the distance between the photon and the event horizon has increased and is greater than r. I mean, the photon's going at the speed of light against a faster than light cascade of space. Since the photon was emitted in the past and it's only been moving inwards since, and it'll continue to do so, we can say that moving towards the future is like moving radially inwards in a black hole, while the past is radially outwards. We get a sort of spatial feel with time inside a black hole. Space now begins to resemble time. Just as time moves in one direction, forwards towards the future, space is moving towards the singularity. It's just moving in one direction inside the black hole. But wait a minute, we've just predicted something bizarre. The singularity is no longer a location in space, it's a future time.